Hello guys, welcome to Ramta Solutions. Welcome to your lesson on mechanical energy. So mechanical energy is your topic in grade 10 physical sciences. Now, this is one topic that to my grade 10s, please note, you will be using this topic as well in grade 12. Okay, so because this lesson is for grade 10 learners, I will not be focusing much of my attention on to how and why you'll be using it in grade 10, but whatever I'm in grade 12, but whatever that I'm showing you in grade 10 will apply even in grade 12. So do not forget this. Okay, all right, so without any waste of time, let's remind each other that when we were in the senior phase, meaning your grade 7 to 9, and I think even earlier in primary school, you used to say that energy is the ability to do work. All right, you said energy is the ability to do work. All right, so we're not going to dwell much onto the definition of what is energy, because you're not really examined on what is energy for your grade 10. Okay, but you will be examined on one. There are two kinds of energy that we will be looking at. Okay, I am not saying these are the only kinds of energy that are available, but I'm saying two kinds of energy that you will be looking at in grade 10. Okay, there are two kinds of energy. One, you will be looking at kinetic energy, and then two, you will be looking at potential energy. Okay, you will be looking at potential energy. Okay, and you then ask yourself, okay, my topic is mechanical energy, why am I not saying mechanical energy as well? Hold on, you will get to understand this later. Okay, so without any waste of time, let's define kinetic energy. Okay, let's define kinetic energy. So what is kinetic energy? Now, this is energy of an object due to its motion. Okay, let me write it down so you may know it. Energy of an object due to its motion. Okay, so we're saying it's energy of an object due to its motion. So we call it kinetic energy. We will use this the symbol EK. So we will say its formula EK is half mv squared, where m is mass of an object and v is velocity or speed of an object. Okay, so obviously this is mass in kilogram, because in physics it's kilograms, and then this is velocity, which is meters per second. Okay, so I want you guys to know this, that energy is a scalar quantity. By now you have done vectors and scalars. It is a scalar quantity, and the units of energy, general units of energy are, okay, let me go to the next page. The general units of energy are joules, which you can symbolize as J. Okay, these are the units of energy. Okay, these are the units of energy. Now let's then head to the second energy, which is potential energy. With this one, I know very well that you have done potential energy in your electricity, what you call it, stored energy. But because here we're in physics, and especially now that we're talking of motion, or in the part of motion, or let me say mechanics, we will define potential energy as one. I want you to pay attention to the definition that I'm going to give you. So I will say potential energy is energy of an object due to its position on the gravitational field relative to a reference level. Okay, I know it sounds long, but I will help make sense out of it. So we said it's energy of an object due to its position on the gravitational field. Okay, on the gravitational field relative to a reference level. Okay, relative to a reference level. So now this one, we say we will call it, maybe let me call it EP here. So we will say this is EP, so EP equals mgh. Okay, EP equals mgh. All right, so this is your potential energy. You remember that m is mass, so this g is called the gravitational acceleration, which is a constant. Right, it is 9,8 meters per second squared, and then this h is the height. However, it is the height above a reference point. Okay, let me just call it a height above a reference level. Okay, let me call it a height above a reference level. So the units are m. Okay, and remember what I said the units of energy are joules, so the units will be joules. So note that potential energy is mass times gravitational acceleration times height. Okay, all right, now we then had to, I will give you an example later. So then we then had to, what is this mechanical energy? Now let me talk of this mechanical energy. Okay, now let me talk of this mechanical energy. So when we talk of mechanical energy, what we're talking of mechanical energy of an object, it is the sum of the object's kinetic and potential energy. The sum of the object's right, so it is the sum of the object's kinetic and potential energy. Maybe I should say at that point. Okay, at that point, at whatever point that you're looking at. So let me say this mechanical energy is EM. However, others can call it E mech, but I will call it EM. Okay, I will call it EM. So I said to you, EM or E mech is a sum of kinetic energy and potential energy, or you can call it, remember the equations of kinetic and potential energy, right? So you can say this is half mv squared plus mgh, right? Because you said potential energy is mgh. Now you also said kinetic energy, its formula is half mv squared. Now this is what your EM is. In other words, what your mechanical energy is. Mechanical energy is the sum of the object's kinetic and potential energy at that specific point. Alright, so the point of that point, it's an addition. I don't think you won't be marked wrong if you end your definition at energy. Okay, you won't be marked wrong, you will still be correct. So now let's imagine this. So I will say this: in the absence of maybe let me say, in the absence of friction, air resistance, applied force, and all other forces, except gravity, okay, and all other forces except gravity, your EM will be conserved. Alright, your EM will be conserved. So what do I mean? If you don't have friction, okay, if you don't have friction, air resistance, applied force, and all other forces you can think of, tension, blah blah, your mechanical energy will be conserved. So what do we mean by mechanical energy is conserved? What we mean is that mechanical energy at point 1 will be equal to mechanical energy at point 2. Okay, remember, this is only when you have friction that's affecting your system. So in other words, this is when you are in an isolated system. Okay, this is only when you are in an isolated system. So in an isolated system, this is where maybe only gravity affects your system. Okay, if only gravity affects your system, you can use this formula. Okay, you can use this formula. You can say EM equals EM at point 1 equals EM at point 2. Otherwise, you hear a lot of people saying mechanical energy before is equal to mechanical energy after. So what we have described here is what we term the law of conservation of mechanical energy. All right, so this is the law of conservation of mechanical energy. So this is the law of conservation of mechanical energy. All right, so now the law of conservation of mechanical energy states in an isolated system, mechanical energy is conserved. Guys, remember, mechanical energy is the sum of an object's kinetic and potential energy. So in an isolated system, mechanical energy is conserved. Right, mechanical energy is conserved. So what you can say is, I mentioned earlier, EM at point 1 is equal to EM at point 2. So remember, this applies only when the system is affected by gravity only and no other forces. If your system is affected by other forces, you must know that mechanical energy will not be conserved. When we say mechanical energy is conserved, we mean one before the other. I mean, one mechanical energy before will be equal to mechanical energy after. Okay, this is what we mean. So a further expansion of this, we can say basically it's EK1 plus EP1, or we can say it's EK2, not all. It's also equal to EK2 plus EP2. Alright? Then what do we do? Is, okay, you by now you know that EK is half mv squared and EP is mgh. Okay, so guys, now this is all that you need for your grade 10 mechanical energy. Remember what I said to you? I said to you, mechanical energy is conserved only when your system is under gravity. If you start hearing words like there is a friction force of whatever and whatever, don't use this formula. Okay, don't use this formula. Or for grade 10, your exam, if you hear them saying maybe at a theme park, for the motors or for the cars to work, they must plug in whatever to the electricity, and then the electricity must ensure that the motor must ensure that the cars are moving. Look, mechanical energy will not be conserved in that system because there is an external force. Right? For mechanical energy to be conserved, there need not be an external force. Okay? There need not be an external force. Okay? Cool. So now we're going to have an example. I believe this example will be sufficient. So let's see. So now with this example says Elena is skating on a ramp. Okay, is skating on a ramp. She starts at the top. She starts at the top of the ramp, which is 10.2 meters high. Which is 10.2 meters high. Now, one, what is her potential energy? These are the questions. What is her potential energy? At the top of the ramp. Number two, what is her kinetic energy? Allow me to write EK. Hey, this thing of writing. Okay, what is her what is her kinetic energy at at h equals 5 meters. So this is when she's moving now. Right? Now, number 3, calculate her velocity at the bottom of the ramp. Okay. Now, before we get into our questions, let me remind you of something. So it doesn't matter, whatever slope is this. If you are sliding down, I want you to know this. As you go down, your EP decreases, but your EK increases. Now, as you go up an incline or a slope or whatever, your EP increases. Why is your EP increasing? Your EP increases because your height increases. And then your EK is decreasing. Okay? Your EK is decreasing. All right? These are the things that I want you to know. All right. So, Now, let's go back to the question. We said Elena is skating on a ramp. She starts at the top of the ramp, which is 10.2 meters high. What is her potential energy at the top of the ramp? That's the first question. Second question, what is her kinetic energy at height equals 5 meters? Okay. The third question, calculate her velocity at the bottom of the ramp. You see, in this question, there was no mention of friction, no mention of air resistance, no mention of applied force, or I don't know whether her skateboard was electrified. It needs to be, I don't know, revved before whatever. No. There was nothing. Okay, so now this means this system is an isolated system, meaning only gravity is affecting the motion. All right, so without any waste of time, let's get into it. So yeah, without any waste of time, let's get into it. So now our answers, we have one. I think I need to mention this. Let me go back to the previous question. Elena's mass is 59 kilogram. Okay, I want to make this 59 kilogram to be her mass combined with that of the skateboard. Okay, so collectively Elena and the skateboard, they weigh 59 kilograms. Okay, all right, so now let's answer the questions. All right, so we said our mass is 59 kilograms. So I want you to imagine something like this. So this is here initially. Let's call it maybe 0.1. The height here is 10.2 meters. And then we also have the bottom here. I don't know what I should call it. Let me call it 3. And then we also have a point here which was, I think it was 5 meters. Okay, so we will call this one 0.2. Okay, we will call this one 0.2. Now, without any waste of time, let's look at this. So the first question said, what is her potential energy at the top? So number one, we said EP equals mgh. What is her mass? It's 59. What is gravitational constant? Acceleration is a constant, so 9.8. And then what is her height? Her height at 0.1 is 10.2 meters. All right, now we have it as, give us the answer. All right, you guys got 5,897.64 joules. I will leave it corrected to decimal places. Okay, now this is our answer. Our answer is 5,897.64 joules. This is her energy where at 0.1, right? Her mechanical energy at 0.1. So now point 2, rather question 2, it said we must calculate her EK at H equals 5. So what we can say here, we can now say, oh, mechanical energy must be conserved. So mechanical energy at 0.1 is equal mechanical energy at 0.2. What is mechanical energy at 0.1? We know mechanical energy is kinetic plus potential. At 0.1, we assume we don't have kinetic because it just started, so we'll say, okay, 0. So this means, kinetic is 0. So we only had potential, which is 5,897, right? So we had 5897,64 equals, what do we have here? We have, so I should have said, okay, maybe I should have used the formulas. Okay, half mv2 squared plus mgh2, right? So we have 5. Okay, you know what? I think I should maybe erase this, and yeah, so I should have it as half. Oh no. Okay, now I should have it as half mv1 mv1 squared plus mgh1. I don't know why I said comma 2 here. I really don't know. Okay, I really don't know why I said comma 2 here, but let me sort it. Let me fix it. Okay, so this is 2. So we have 5897,64 equals half, what is the mess? 59 v2 square plus 59 9.8 into 5, right? So we have this one, we leave it as it is. 5897,64 is equal to 29.5 v2 square plus 59 times 9.8 times 5. It is 2,000. It is 2,891. Okay, let me go to the next page. 2,891. Let me go to the next page. So I think we had think we now have, I'm not sure, we should be having, let me see, minus 5 into 9.8. So we have let me make sure that I write the right things here. Okay. Ooh. Okay, so our answer is 3006. Let's see. 3006,64 is equal to 29 v2 squared. So this answer divided by 29, it would be, maybe let me write it here, v2 square equals 103,67724. I think 5 decimal places won't really affect my answer that much. So v squared equals square root of this guy. So square root of this guy is 103,67724. Now, what is it? Now our answer is v2. Therefore, we have v2 equals 10,18 meters per second. So you see, now we have calculated. I lost it. We are supposed to, thank you for reminding me. We are supposed to calculate EK. Okay, we're supposed to calculate EK, not V. So all right, it doesn't matter. From here I can say thank you for reminding me. Half mv squared would be half into 59 into, I think somehow I found it, so no, let me not do this. I think somehow I found it. We can say ek equals ek equals 3006,64 joules. So thank you guys. So this was our ek. All right, this was our ek. So for those that I could have maybe confused, I will quickly say what we had done is, let me go back. Okay, and then so what we could have done, we could have left this part as it is. Okay, we could have left this part as it is, and then when we left this part as it is, maybe let me write in a different color. Maybe I could have left it as ek2, okay, and then this whole thing is ek2, but I could have left it as ek2, and then this is again ek2. So this is kinetic energy at 5 h equals 5 meters. Okay, so thank you for reminding me. Thank you. So now the final answer for the final question, which was number 3 said we must calculate the velocity at the bottom of the ramp. Again, em at point 1 is equal to em at point 3. It is not a mistake. For as long as there is no friction, mechanical energy will be conserved, right? So you remember that mechanical energy here, we used to say, maybe let's say this is ek. Okay, you know what, I shouldn't write ek here. Okay, ek at point 1 plus ep at point 1 here, let me just do it, equals ek at point 2 plus ep at point 3, not point 2, point 3. Okay, now ek at point 1, we said it was 0, and we found our ep at point 1 to be, if my memory serves me well, we found it to be what was it? I think it was 595. Okay, let me check. 5897,64. Now ek at the bottom is, this is the one that we are looking for right now. Now ep at the bottom, look at it, we had point 1 here, point 2, and then point 3 is the bottom. So what is the height here at this point? At this point the height is 0, so I'm going to leave it as 0. Therefore ek at point 3 is 5897,64. However, the question says we must calculate we must calculate the velocity, but you and I know that ek equals mg equals half mv squared. Right? So the ek we're looking at here is the ek at the bottom of the ramp, right, which was 5,897,64 joules, right? Joules equals half. What is the mass? The mass we're looking at is 59. It doesn't change. Now the velocity here is velocity at the bottom. Let me call it v3. Okay, now let's see. 5897 divided by 5897,64. Okay, let me leave it like that for now. Let me sort out the right hand side. Equals 20 0.5 of 59, meaning half of 59 is 29.5. Okay, it's 29.5. Oh boy, 29.5 V3 squared. So 5897.64 divided by 29.5. What is it? It is, let's see, V3 squared equals 5897.64 divided by 29.5 is 199.92. Therefore, what is the velocity at the bottom of the slope? It is this guy. Remember, guys, I am writing these things in this way so that you make sense of the calculations. You don't make mistakes when you calculate. Okay. Otherwise, from me, if it was for me, I would have given my answer from this point. Okay. But because I'm working with you guys, you have to see this until you master them. Okay. Until you master them. So now we want the square root of this 199.92. What is it? It is V3 is 14.14 meters per second. So this is the velocity at the bottom of the ramp. It is 14.14 meters per second. With that being said, you have now mastered your mechanical energy topic. Remember, you will apply all these strategies whenever you come across this question of or this topic of mechanical energy. By the way, it is question 5 in your grade 10 examinations. Okay, so with that being said, from me, I think, guys, I've given you almost everything you need. Remember, in summary, when we talk of mechanical energy, especially the law of conservation of mechanical energy, there must never be any friction, tension, and blah blah. There must only be gravity that affects the motion. If your question does not say to you anything about friction and stuff, you must know that you can apply law of conservation of mechanical energy. Okay, and remember, mechanical energy at point 1 is equal to mechanical energy at point 2. It does not matter whether the point is immediately next to it or down below. For as long as mechanical energy is conserved, or for as long as your system is isolated, mechanical energy will always be conserved. So with that being said, that's a wrap from me, guys. Till we meet again, bye bye.